Now we are going to use kinetic pressure of an ideal gas to deduce the expression for the following laws, and one of the law we are going to look at is the Dalton's law of partial pressure. So we need to understand what partial pressure is. Now partial pressure is the individual pressure which a gas would exert if it alone occupy a vessel or a container originally occupied by the mixture. So now let us look at the vessels here. I have a vessel here. Now this vessel will have gas 1 and gas 2. The total pressure here, let's say, is 10 kilopascals. Now, when you remove gas 1 and you put it in that same vessel, same volume, and say it exerts a pressure of 7 kilopascals, that implies that was its partial pressure. That's the pressure it contributed to this 10 or to this total pressure. So gas 2 would therefore contribute 3 kilopascals, because now we are going to see Dalton's law. Now according to Dalton's law, the total pressure of the mixture of of ideal gas is the sum of their partial pressures at constant volume and temperature. So the conditions here must be constant. Volume and temperature must be constant for Dalton's law. So we shall state Dalton's law of partial pressure as the total pressure of a mixture of an ideal gas is the sum of the partial pressures for each gas at a constant temperature and volume. So that is Dalton's law of partial pressures. So this is the total pressure exerted by the mixture of gas. So the pressure of gas 1, we have seen 7 kilopascal, that of gas 2 to be 3 kilopascals. So these are the partial pressures, the pressure which the gas would exert if it occupy the vessel alone. Now the total pressure is now the sum of these partial pressures, and that is the Dalton's law. But you have to note that temperature and volume are kept constant. So the total pressure will be equal to the sum of the partial pressures. And the partial pressure I have seen is the individual pressure which the gas would exert if it alone occupy a container originally occupied by the mixture. So now, after knowing what partial pressure is and Dalton's law, we are going to derive the expression for Dalton's partial pressure. In other words, if we have a mixture of two gases, the total pressure is given by P1 plus P2, where P1 and P2 are partial pressures, and this is the total pressure. And now this is the Dalton's law, which we are going to derive using a kinetic theory. The kinetic pressure of the gas. So now we know that the kinetic pressure is given by a third times the mass times the number of molecules divided by the volume times the mean square speed. So we are going to consider a mixture of two gases. A mixture of two gases. This would mean that we have P1 equal to a third M1 N1 over V1 and C1 squared, and P2 will be equal to a third M2 N2 over V2 C2 squared. But note that in Dalton's law of partial pressure, V1 is equal to V2, so we shall call it V. And now when we get P1 plus P2, we must get the total pressure. That is the aim. So we shall say P1 plus P2 will be equal to, now we shall get a third times 1 over V. Then we shall have, let me say a third times M N1 M1 over V plus a third times N2 M2 over V, and this is mean square. Even here we have a mean square. Okay, so the volume is the same. Now we are going to bring in the temperature. We know that kinetic energy is equal to a half mc squared, and this is equal to 3 over 2 kb times. This is very important, so we shall find a way of introducing it here. So let us say P1 plus P2. Now I'm going to multiply with the 2 and I divide with the 2 in these two terms. So we shall get 2 over 3 2 over 3, then N1 over V times, now I have to divide by 2, so I have M1 C1 squared. I do the same in the last term. I will multiply with the 2, so N2 over V times a half, then M2 C2 squared. I think you can now see that this term here is for kinetic energy. We understand that this is kinetic energy, so we can as well write P1 plus P2 equal to 2 over 3 N1 over V. Now here we are going to put 3 over 2, Boltzmann is constant. Now this will be for temperature 1, then plus 2 over 3 N 2 over V Then we shall have V over 2 Kb and T2. Another thing you need to note, just like volume, which is constant, even temperature is constant, so T1 is equal to T2 is equal to T. So we can as well multiply and factorize this T out. So we are going to have P1 plus P2 to be equal to, now we shall have 2 over 3. I'm factorizing 2 to the common terms, 2 over 3, then times Kb T, because T is the same, so Kb is common, then over V, because V and V is the same. So what remains, there is also 3 over 2 3 over 2. So now we shall be left with n 1 plus n 2. Okay, so this is the same because this is representing the temperature, representing kinetic energy, where T1 is the same as T2. So now you can see the 3 goes and the 2 goes. So you have P1 plus P2 equal to Kb T over V, then N1 plus N2. But now N1 plus N2 is equal to N, the total number of molecules. So we shall get P1 plus P2 equal to Kbt over V times N. But now we need to note that 3 over 2 Kbt is the same as a half m c squared, implying that 3 Kb, that Kbt will be equal to a third mc squared bar. So we are going to substitute this Kbt with this. Kb is the Boltzmann's constant. So let me create space. So we shall say that P1 plus P2 will be equal to a third mc squared. So that is Kbt, then divided by V times N. And we can see that now this is, so P1 plus P2 is equal to a third Nm over V c squared bar, and this is a very common expression in which we know that it stands for pressure. This stands for pressure. Remember, this is the total number of molecules, this is the total mass, and this volume is constant. So this stands for the pressure, which is representing Dalton's partial law. Dalton's law of partial pressure. So P1 plus P2 is equal to P. So this is what we have got. So that is how we derive the expression for Dalton's law of partial pressure.